Okay, come back to the slide. Okay, after we have, so I've talked about the resistance, capacitance, and inductance. Okay, for resistance, it reacts in these only these both DC and AC system. For capacitance and inductance, it will respond to the circuit only when you have some switching or the circuit is alternating current circuit. Okay, for DC circuit, capacitance and inductance will not work. Okay, it will work only when there's something changed in the circuit, like when we have some switch. Okay. And another equipment in the electrical engineering field is the transformer and alternator. Right? The inductor are located in both transformer and alternator, allow the voltage conversion and current generation. Okay, and the transformer convert the voltage to another level. Okay, on the other side. And for the alternator is convert the mechanical, right? The mechanical power to electrical power, right? Or electricity, right? It's convert mechanical power to electricity. If you drive, the alternator will get the electricity, right? Or sometimes we call the generator. So if we convert electricity to mechanical power, we call it motor, right? Electricity to make power. This we call this equipment as a motor. This equipment as a generator. Okay, for electrical source, we have so many types of source, but mostly we talk about the ideal source. Ideal source is mean, for example, the constant voltage source here. The voltage source is here. We call this constant source. Ideal. It means the voltage is always constant. Okay, but in practice, the voltage is maybe just near constant, right? Not exactly constant, but ideally it's constant. So we have the current source, right? Or constant current source. Constant, ideal current source. Yeah. Okay. So this is the element that capable to supply the energy to the circuit, right? Yeah. We also have control voltage source, control it. Not constant, but this voltage source is depending on another variable in the circuit and control current source. Okay. Here, control current source. It's controlled by voltage or current from another signal, right? Or we can call this type of source as dependent source. Constant source we can also call independent source. Okay. For example, This is 12 volt, right? This is independent source. It's always 12 volt, okay? During our computation, it's ideally 12 volt, okay? Never change. And we also have dependent source. For example, okay, maybe I1. This is 5I1 volt. Okay. This is dependent source. So the voltage of the source is depending on I1. Okay, how much I1 we need to solve it, and then we get this voltage. Okay, depending on I1. Okay, if you check the circuit, the voltage is also changed. Okay, so this is a simple circuit, right? So this circuit may be more complex to solve. Okay, it's more complex for you to solve. So, have you ever solved this type of circuit? No. Not sure. Cannot remember.
Yes.
Maybe, right? But you cannot remember. This is okay. This is sure, right? You have ever tried to solve this type of circuit, but this is maybe cannot remember, right? Okay. And maybe more specifically, if we draw the source in this symbol, this is it means maybe more specific for battery, right? For battery, it's maybe like this, or DC source, constant source. Okay. So when we see this symbol, right? We know it for circle, right? Circle symbol. This is a constant source, right? But this type of symbol is dependent source, right? Controlled source, right? This is control source. Yeah. Okay. For ideal voltage source is here, right? It's always constant. We can use Ohm law. V equal to I into R, right? For this circuit, okay. And for the current sources, also current flow. If we connect this if we connect this source to the resistance, right? The voltage across the resistance divided by R will be equal to this current, right? Yeah. This is the ideal source. And this is dependent or controlled source, right? It's depend on the different voltage or current in the circuit, right? Yeah. Okay, the electric circuit principle. I think this type of circuit is not difficult to solve, right? If you have the resistor connect in series, right? If the resistor is in series, we just add it together, right? Add it together. So we have total resistor R1 plus R2 plus R3 is total, right? And then the current will be Vs divided by R total. Okay, this is easy for you, right? Still easy for you. Okay. Okay. And this is a series circuit. We call this circuit as a series circuit, right? If we connect the equipment in series, right, like this, we have battery, we have 2 lamps. if one lamp is broken, the circuit become open, right? We cannot use another lamp like this, right? Okay. And the voltage across each lamp will be lower than the voltage of battery also. Okay. In series circuit, the resistance, the total resistance is the sum of the resistance together, right? The inductance also as a sum of the inductance. The voltage of the source also increase, right? We add it together. But for capacitance, it will the 1 by total capacitance equal to 1 by C1 plus 1 by C2 until 1 by Cn. Okay, this is the multiple element in series circuit. Okay, this is the resistor in series, right? The total resistor is the three R1, R2, R3 add together. Okay, and the current flow will be V divided by R total is 12 divided by 4,380 ohm, right? We have 2.74 milliamp. Okay, this is not difficult. And the voltage source in series also we add it together, right? Here in this case, the total voltage will be 27 volt like this. Okay, what happens if we reverse some battery? If you cancel each other, right? The sign will change, right? Okay, I think you understand that. And for the resistor in parallel, here, right? For resistor in parallel, 1 divided by total resistance would be 1 by R1 plus 1 by R2 plus 1 by R3, right? This is the property of resistor in parallel, right? Okay. And the current flow is in each resistor is not the same, right? And the voltage across each resistor are the same here, right? So in parallel circuit has more than one current path, right, branching from the energy source like this. The voltage across each resistor are the same. So if you connect the two lamp in parallel, if one lamp is broken, another lamp still be used. Okay, right? So that in your home or in this building, we connect the equipment in parallel, right? Okay, each receptacle or each plug we connect into parallel, right? Connect parallel together. All equipment in the industry usually we connect it in parallel circuit. Okay, so if we have the resistance connect in parallel, we add it with this formula. If we have the inductance in parallel, also we compute the total inductance by this formula, and for the capacitance we just add this together, right? And for what about the source? If we connect the source in parallel, what happens? The voltage across the source will be the same as one single source, right? Okay, if we connect 12 volt, 4 cells of battery 12 volt in parallel, 12 volt for each cell. The terminal of this circuit will be 12 volt, right? But we have more energy, right? It can supply more energy from this circuit. Right? We can use this circuit for longer time than one single cell, right? But still we have the same voltage. But if we want to increase the voltage, we connect it in series, right? In series form. Okay. Okay. This is an example on the resistor connect into parallel. So the total resistance will be 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3 is 386 ohm, right? Okay. You can check this way by yourself. But usually my students say that, oh, I believe, I don't need to check it. Okay, just believe, you don't need to check. Okay, and the current flow, okay, is the voltage across. What is the voltage across? Is 5 volt, right? The current will be 5 divided by 386, right? Is the current here. Ampere. Okay. I think it's good for today now. So any question? Just revise your basic, right? So next time I will start the second slide. Okay, I think we go into the detail of that textbook. Okay, I start with the basic circuit first, and we will go deeper and deeper. The circuit will be more complex and more complex. Okay.